In the spring of 2017, I decided to build a decorative windmill to put on my lawn. This video describes the windmill and some of the details of its design and construction. I am posting it to assist those who are working on similar projects. They may find some of the information helpful. The windmill base stands 5.5 feet tall, and the blades are 3 feet long and 10 inches wide. This makes the overall height about 8 feet. The base is hexagonal, with each side 20 inches long at the bottom. The structure on top of the base can be manually rotated to face the blades into the wind. The windmill is constructed using pressure-treated lumber, plywood, and tongue-and-groove cedar planking. The turbine shaft is a go-kart axle mounted on pillow block bearings. The turbine hub is constructed using 2 go-kart hubs. The base sits on 6 pieces of 2x6. There is a 1.5 inch hole drilled through each 2x6. Attached to the 2x6s are 6 2x4s cut to form a hexagon. 6 vertical ribs are attached at the points where the 2x6s come together. These lean inwards to give the structure its cone-like shape. These ribs are ripped from 2x4s. The side ribs are cut to match the 60-degree angle formed where the 2x4s meet. The ribs are attached to the base frame with metal angle brackets. The turbine hub is made from 2 go-kart wheel hubs. The 4-blade ribs are sandwiched between the hubs with 4 through bolts. Angle brackets and heavy piece of plywood on the front of the hub add strength to prevent the blades from coming off at high speed. The blades are made of plywood and are attached to the ribs with screws. An angle is cut on the edge of the ribs where the plywood is connected to pitch the blades at about 35 degrees. The structure behind the blades contains the bearings. It is made from plywood with a removable roof so the bearings can be serviced. The structure is mounted to the base with a single central bolt. I built the windmill in my garage. It was an excuse to buy a miter saw and a chance for me to get some practice working with compound angles. The blades turn very easily. Even a slight breeze of about 5 miles an hour is enough to spin them. The windmill's shaft extends out the rear of the bearing house. If one wanted to power something, they could make the bearing house shorter and attach a pulley to the end of the shaft. This photo shows the forward bearing and the shaft. The bearings are bolted to a 2x6. The bearings are mounted on a rubber pad. This allows them to align with each other because they are not self-aligning bearings and no wood base can be counted on to be perfectly flat. On top of the base, under the metal pan, are 2 thick pieces of plywood. The plywood is waxed and acts as a thrust bearing so the top of the windmill can be rotated manually. The pan is there to protect it from the weather. If one wanted to allow the windmill to weather vane into the wind, a suitable lower friction thrust bearing would have to be used. A rudder would have to be attached to the rear of the windmill also. The plywood blades are pitched back at about 35 degrees to the vertical. This was not determined through any calculation, but rather just an intuitive guess. I knew that a relatively steep angle would provide a decent amount of torque and therefore rotation at low wind speeds. I used plywood because I had some handy. I made the blades replaceable by screwing them on so I could experiment with different blade widths and materials in the future. Ideally, I would have made them out of acrylic sheet for weatherability, but the plywood seems to be weathering better than I anticipated. The base frame is covered with cedar tongue-and-groove boards. One section is removable to allow access to the pivot nut. This access may also come in handy if the bees or hornets decide to make it a home. This photo shows the rear of the bearing house. The shaft protrudes through the back of the structure. 2 pins at the peak, one in front and one in the rear, allow for easy removal of the roof to gain access to service the bearings. The windmill is bolted down to 6 concrete patio blocks. This lowers the center of gravity of the entire windmill, making it more difficult to be toppled by the wind. So far, maximum wind speed it has been exposed to was about 50 miles an hour. It did not budge. A counterweight, in this case 2 bricks, is hung from the rear to balance the blade assembly in the front. The vertical dowel at the rear has a string attached to the top to show the relative wind direction. One of my concerns when designing the windmill was that it would fly apart at high speeds because of centrifugal force. That is why I made the hub so robust. It turns out that this is not the case. I have not seen the blades exceed about 120 RPM. I have a theory why this is the case. The force of the wind on the blades increases as the square of the wind velocity. Countering this is the aerodynamic drag on the rotating blades. This force increases as the cube of the blade's velocity. This drag makes the windmill self-governing, limiting the maximum speed it can reach.